Alright, this quick little video is going to help show you guys something on acceleration that some of us are a little bit confused on. One thing that I wanted to address first was I wanted to address the tangents. And what I mean by the tangents is one of the questions that was asked throughout the day was, how do you figure out the tangents? Well, let's take a look at this. Let's say I wanted to know the instantaneous velocity at that point there. Well, one of the things you're going to have to do is you're going to have to make a tangent. And if you remember, the tangent is a parallel line that's touching that. Well, how can I be sure that that tangent is the exact slope at that point? Well, if you remember back to the lab that we had, there was something called mid-time. Mid-time. Okay? Well, that mid-time is basically, like it says, the time in the middle of these points. So if you kind of look at this point right here is in the middle of a couple of points. It's in the middle of this point here and this point here. So if I were to take these 2 points and I were to actually connect them using a line, that slope would represent the slope at this point. Okay? Now there is a question like this on the test, so you need to understand how to do this. So basically when you do a tangent, your mid-time is going to be the slope of the 2 points you connect here. Okay? So if I wanted to figure out the slope at this point, then I would connect this point here with this point here. I'd just draw a line between them and then I'd calculate the slope by taking the rise and dividing it by the run. Now the other question that was raised was on question number 4. And the question with question number 4 was that you had to understand the equation. Okay? Now remember, the most important thing when it comes to any physics equations is know what those letters represent. So we have some basic letters we need to understand. The first one being one that we should all know. I mean, the first one being velocity. It's going to be a V. The only difference is here you're either going to have VI or you're going to have VF. Now the key difference here are those letters underneath. I meaning initial, and F meaning final. Okay, so the initial is just basically when you started, the final is when you stopped. All right. The other ones you need to be aware of is you need to be aware of A. That should be pretty obvious. That should be acceleration. You need to be aware of X. That's going to be position. We all should know delta by now. That's going to represent a change. And then the last one you're going to have to worry about is going to be time. Alright, so those are the different variables that you're going to have. And the equation that becomes really important in question number 4 in the review, this was this equation. It's VF, so velocity final, squared is equal to 2 times the acceleration times the change in position, so delta x, plus the initial velocity squared again. So if you take number 4, and I'm just going to go ahead and read it because I don't have it on the paper right here. Number 4 asks, tailback initially running at a velocity of 5.0 meters per second becomes very tired and slows down at a uniform rate of 0.25 meters per second squared. How fast will he be running after going an additional 10 meters? So what you need to do, and this goes with any word problem, and I hopefully you guys have gotten these tricks as your years have gone on, but it's pretty simple. You write down what you have and you write down what you need. Okay? So what I'm going to do here is I'm going to highlight this equation just so I can bring it with me later. And I'm going to bring up the actual problem. So here I brought the problem up. So let's go ahead and let's actually go through this. So I've got some important information. First piece of information I have is I have this right here. Okay. Then I have this right here. And then I have this right here. But there's a catch. This right here, this 0.25 meters per second squared, there's another piece of information that's really important. And it's actually right here. It says slows down. Okay? That becomes really important a little bit later. We'll talk about it in a second. So, a tailback initially running at a velocity of 5.0 meters per second, well, I hope that if we take this and we put it right above it, let's put it below, because you can't really see it up there. So there's our equation. Well, guess what? These two, are those work? No, because that says velocity final. So we know it's not going to be that. However, initial, we have our initial velocity. So what I'm going to start doing is I'm going to actually start writing down the important things that I have. A good way of saying it is, what do I have and what do I need? So I know I have an initial velocity. Okay? So I'm going to write that down. I have a VI of 5.0 meters per second. Okay? Then if I continue, it says slows down at a rate of 0.25 meters per second squared. Well, meters per second squared tells me right away, because that unit tells me that's an acceleration. So 0.25 meters per second squared, that's an acceleration. So my acceleration is 0.25 meters per second squared. But the question I have for you is, what's the sign? Well, this right here is the clue. Slows down. This guy's running at a speed already. If he's slowing down, these two numbers cannot be the same sign. If he's going a positive 5, this has to be a negative 0.25 meters per second squared, because he's slowing down. Remember the concept of the two arrows pushing on each other. If I have an arrow pushing this way and I have my acceleration right here, he's going to make that arrow get bigger. Okay? But if I have an arrow pushing this way, he's going to make that arrow get smaller. Okay? So this is going to have to be a negative. The last thing I'm given is I'm given the 10 meters. The 10 meters is basically the change in position. The reason why I can say that's the change in position is because I gave you no starting position. So what can I assume the starting position is? It's going to be 0. So I can say that my change in position is equal to 10 meters. Why? There is no starting point. You assume 0. The last thing I want to know is how fast he will be running. Okay? That's going to be a final velocity. So what I'm going to do there is I'm going to actually write it down. I'm going to have velocity final is equal to unknown. So now all I have to do is I have to take all of this information down here and plug it into this formula right there. Okay, so let's plug it in. I don't know my final velocity, so that's going to stay unknown. So VF squared is equal to, I know my acceleration, so it's going to be 2 times negative 0.25 meters per second squared. Okay, and I'm writing this really big, so actually I'm going to erase all this real quick so I can write it smaller. So I can fit it all on the page. Okay, so VF squared is equal to 2 times negative 0.25 meters per second squared times delta x, which is 10 meters, plus my initial velocity, which is 5.0 meters per second squared. And that whole thing is going to be squared. Okay? Now, there's one slight problem with that, and that's going to be the squared up front here. So to actually get rid of that, obviously, to get rid of a square, I square root, but then I got to square root both sides. So to actually get the real answer, I have to actually go through, I have to erase that, and I have to square root this whole side. So what I'm going to do is I'm going to plug that into my calculator. And when I plug it into the calculator, I get, or at least you should get, around 4.47. And if I cancel out if I use all the units and so on and so forth, what you'll end up having is you'll end up having meters per second. Okay? And don't forget the units. So that's my answer. All right? So, if there are any questions on that, shoot me an email. But hopefully this will help get you guys a little bit more prepared for the test on Wednesday.